Okay, so good day everyone. So this time we're going to have a discussion of data preparation and data cleaning. So, uh, when using data, most people agree that your insights and analysis are only as good as the data you are using. So essentially, garbage data is in a garbage data in is garbage analysis out. So data cleaning, also referred to as a data cleansing and data scrubbing, no, is one of the most important steps for your organization if you want to create culture around quality decision making. So to give us more details about the topic, let us all welcome our presenter. Go ahead.
Okay, so good morning po. We are the group 2 and our topic is about data preparation and cleaning. So these are the reporter, Carl Pontillas, Kevin Camantigue, Luis Solarilla, and Jericho Villonar. So as for our table of contents, we are going to tackle about introduction, the data sources, data collection and acquisition, um, data cleaning, data transformation, data reduction, and data pre-processing. Okay, for our first reporter, we have Kevin Lee Camantigue.
So, good day everyone. I'm Kevin Licamantigue and I'm going to discuss about data preparation and cleaning. So, what is data preparation and cleaning? Data preparation and cleaning refer to the process of cleaning and transforming data into a format that is suitable for analysis. This involves identifying and correcting errors, removing duplicate or relevant data, and also ensuring that the data is consistent and accurate. So the concept of data preparation in cleaning is that it is an essential process in data analysis. So what is the importance of data preparation and cleaning in data analysis? So we all know that raw data is often messy and unstructured, and also it is difficult to work with. That's why data preparation and cleaning is necessary. Data preparation and cleaning is critical in data analysis process because they ensure that the data is reliable and can be used to generate insights in information decision making. Next slide, please. So, data preparation and cleaning. Data preparation and cleaning include a range of techniques and processes designed to improve the quality of and accuracy of data, including data integration, data cleaning, data transformation, data reduction, data formatting, and standardization and data validation. Data integration involves combining data from multiple sources into a single dataset, or how data transformation involves converting data from one format to another. There are common challenges that arise during data preparation and cleaning, such as dealing with inconsistent data formats, resolving conflicts between different data sets, or identifying or removing outliers. It is a critical step in data analysis because the quality of and accuracy of the results obtained from analyzing data depend largely on the quality of data that is analyzed. There are some tools and technologies that are commonly used for data preparation and cleaning, such as ETL, or which stands for Extractor Transform and Load, and data wrangling tools and data quality management platforms. Next slide, please. So what are the benefits of data preparation? So first is it fixes errors quickly. Data preparation can identify and correct errors such as missing values, inconsistent formatting, or duplicate entries. This can affect the accuracy of analysis. Second is producing top quality data. Data preparation helps to improve the quality of data by removing errors, inconsistency, and duplicates from the data. This helps to identify the missing data, the outliers, and also the anomalies that can affect the accuracy of the analysis. By cleaning and transforming the data preparation can produce high quality data that is accurate and complete and also and consistent. So the third one is to make better business decision. So accurate and reliable data can help business to make better decisions, such as identifying new opportunities, improving operations, and also reducing costs. Data preparation helps to make data more accessible. And also, it helps to make data understandable and useful. This enables decision makers to make more informed decision based on the insights generated from data analysis. So the fourth one is to superior scalability. So um, one of the benefits of data preparation is superior scalability because proper data preparation can ensure that the data can be easily scaled and integrated with new data sources. This allows business to grow and adapt to change the market condition. Next is future-proof. So by properly structuring and organizing the data, data preparation can future-proof data by using new applications and technologies. And last is accelerated data usage and collaboration. So by standardizing and structuring data, data preparation can accelerate data usage and enable better collaboration between teams, leading to faster insight and better decision making. So yeah, that's the benefits of data preparation. Next slide, please. So what are the different sources of data? First is primary data. So primary data refers to data collected from the source. This type of data is usually collected through survey, interview, observation, experiments, and other data collection method. The second one is secondary data. Now, secondary data refers to the data that is already been collected by someone else or from different purpose. This type of data is obtained from sources like government publication, academic journal, reports, and other public sources. The next one is internal data. Now here in internal data, it refers to the data that is collected by an organization or business for their own use. This type of data may include sales data, customer data, employee data, financial data, and other operational data. The next one is external data. Now, external data, it refers to the data that is collected by an organization or business or from an external source. Now, here in this type of data, this may include some market research data, competitor data, social media data, and other publicly available data. The next one is sensor data. Now, here in sensor data, it is a kind of data that is collected from various types of sensors, such as temperature sensors, pressure sensors, or motion sensors. This type of data is usually collected in real time and in various industry, like healthcare, manufacturing, and transportation. And last is web data. Now, here in web data, it is the kind of data that is collected from website, including web pages, web services, and social media platforms. Now, this type of data is often used for digital marketing, like web analytics in other industries. Now, these are the common sources of data that is used in data analysis. However, this type of data and data sources may vary depending on the specific project or analysis. Next slide, please. So what are the types of data? So the first one is categorical data. Now this type of data represents categories or labels like gender, color, or type of product. The next one is numerical data. Now this type of data represents numerical value like age, weight, or height. The next is ordinal data. Now, this type of data, it represents values that have specific order or ranking, like educational level or customer satisfaction levels. The next one is time series data. Now, this type of data represents data collected over time, such as stock prices or weather data. The next one is spatial data. Now, this type of data represents data that is related to physical location, like GPS data or maps. And the last is text data. Now, this type of data represents text-based data like reviews, comments, or social media posts. Now, these are the types of data that are used in data analysis. It is important to understand the type of data that is being analyzed to choose sorry, to choose the appropriate statistical method and technique. So yeah, next slide please. So what are the types of data structure? So the first one we have is linear data structure. So as the name suggests, linear data structure organize data in a linear manner, which means that data elements are arranged sequentially, one after the other. For example, linear data structure include like array, linked list, stacks, and queues. The second one is tree data structure. Now, tree data structure organize data in a hierarchical mode manner, which means there is a order with a single root node at the top and a child node branching out from it. Now, trees are often used to represent hierarchical relationship between data elements, such as in file system or organizational charts. The next one is hash tables. Now, hash tables are used to store key value pairs, with each key being mapped according to the corresponding value using hash function. Now, hash tables provide fast access to values based on their keys, making them useful for implementing data structure such as dictionaries and associative arrays. And the last is graph data structure. Now, data structure consists of set of vertices or nodes connected from each edges or arcs. Graphs are used to represent a complex relationship between data elements like social network and node network. Graphs can be directed or undirected, weighted or unweighted, and can have cycles or be as cyclic, or not displaying or forming part of a cycle. So in the end, this data structure has its own strengths and weaknesses, and the choice of which one to use depends on the specific problem being solved and the requirements of the application. So that's all for me. Thank you.
Data collection data collection and acquisition. So the common data acquisition consideration. Data acquisition is the process of sampling signals that measure real-world physical conditions and converting the result sample into digital numeric values that can be manipulated by a computer. Best practices in data collection and acquisition. Here are some best practices for data collection and acquisition. Identifying the purpose of the data. Choose the appropriate data collection methods. Use reliable source. Minimize biases. Ensure data quality. Maintain data privacy and security. Data collection methods. The following are the 7 primary methods of collecting data in business analytics, such as survey, transactional tracking, interviews and focus group, observation, online tracking, forms, social media monitor. Two methods of data collection. First is the primary, first-hand data collected by, by the data researcher. The second is secondary hand, the data collected by the other parties. Data cleaning. So what is data cleaning? Data cleaning is a process of identifying correct, correcting errors, inconsistencies, missing values in data. It involves removing irrelevant data, handling duplicates, and standardizing the data format. Common data quality, incomplete data, missing values or fields in the dataset. Next is inaccurate data. Data values are incorrect or not up to date. Next is inconsistent data. Data is recorded differently across different sources. Next is duplicate data. Data is recorded multiple times. Data cleaning and technique. Handling missing values, removing the records with missing values. Next is handling the outliers, transforming the data to make the outliers less influential. Next is handling duplicates, identifying the identical record. Next is standardizing data, converting the data to a consistent format. The next is handling inconsistent data, transforming data into a consistent format. Last is the performing data profiling, processing and analyzing the data.
Good morning, everyone. Let's now proceed to data transformation. Next slide, please. What is data transformation? Data transformation refers to the process of converting raw data from its original format into a format that is more suitable for analysis, modeling, and other data-related tasks. This process typically involves cleaning, rephrasing, and aggregating data in a way that allows for easier analysis and interpretation. Data transformation may also involve applying mathematical or statistical operations to the data, such as normalization, scaling, or feature extraction. Data transformation is a critical step in the data analysis process, as it helps to ensure that the data is in a suitable format for use in statistical models, machine learning algorithms, or other types of data-driven applications. It can also help to identify and correct errors, inconsistencies in the data, which can improve the accuracy of reliability of any subsequent analysis or models. Next. So here we can see the different types of data transformation. The first one is cleaning, aggregation, enrichment, normalization, and integration. So now let's proceed to cleaning. Next step, cleaning. Cleaning is a crucial step in data transformation as it involves identifying and correcting errors, inconsistencies, and other issues in the data that may affect its accuracy or usability. Cleaning typically involves a range of tasks including removing duplicates, handling missing or incomplete data, identifying or removing outliers, and lastly, correcting errors or inconsistencies. Next one is aggregation. Aggregation is a process in data transformation where data is combined and summarized into a smaller set of values. The purpose of aggregation is to simplify the data and make it more manageable for analysis. Aggregation can be performed in different types of data, including numerical and categorical data. For numerical data, aggregation can involve summarizing the data into statistical measures such as mean, median, mode, standard deviation, or range. For categorical data, aggregation can involve grouping the data into categories and summarizing the count of percentage of observations in each category. Aggregation is often used in data analysis to reduce the complexity of the data and make it easier to interpret. It can also help identify patterns or trends in the data that may not be apparent when looking at individual data points. Next one, please. So now we're here at the normalization. Normalization is a process in data transformation that involves rescaling numerical data to ensure that each feature has equal importance in the analysis. So the aim of the normalization is to transform the data into a standard scale or range, typically between 0 and 1 or 1 and 1. This makes it easier to compare and analyze different variables in the datasets without any bias or distortions due to differences in units or scales of measurements. Normalization is commonly used in machine learning and statistical analysis to prepare the data for modeling. It can also help to reduce the impact of outliers and make the data more robust to changes in the scale or range of the input variables. Next one. So the next one is integration. Integration is a process in data transformation that involves combining data from multiple data sources into a single data sets. The purpose of integration is to create a comprehensive and unified view of the data, enabling more effective analysis and decision making. Integration can be complex process, as the data from different sources may have different formats, structures, or levels of quality. The process typically involves identifying common data elements and creating a mapping or schema that describes how the data will be combined. Integration, excuse me, integration can be performed using different methods, including manual integration, which involves manually combining the data from different sources into a single data sets. The second one is data warehousing. This involves creating a centralized repository for storing and managing data from the multiple sources. The last is application integration. This involves integrating data at the application level, where the data is shared between different softwares, application, or systems. Next one. And lastly, enrichment. Enrichment is a process in data transformation where additional data is added to an existing datasets to provide additional context, insights, or meaning. Enrichment can involve adding data from a different source to supplement or enhance the existing datasets. For example, adding demographic data to a customer dataset can provide additional insights into customer behavior and preferences. Enrichment can also involve adding metadata, such as tags or keywords, to help categorize or organize the data. This can help improve searchability and make the data more accessible to the users. Enrichment is often used to improve the quality and usability of data, as it can provide additional context and insight that may not be apparent in the original datasets. It can also help to identify relationships and patterns in the data that may not be evident when looking at the data isolation. That's all for me, everyone. Next one is data introduction, which is going to be presented by Jericho's Avillionar.
Hello po. Good day everyone. I am Jericho Billionaire and I will be tackling about data reduction. So what is data reduction? So data reduction is the process of reducing the amount of capacity required to store data. Data reduction can increase storage efficiency and reduce cost. Storage vendors will often describe storage capacity in terms of raw capacity and effective capacity, which refers to the data after reduction. So there are two types of data reduction. There is thick and thin provisioning. So thin provisioning helps to avoid wasted physical capacity and can save business on upfront storage costs. However, thick provisioning has the benefit of less latency because all storage is allocated at once when virtual machines are created. So these are the visualization of thick and thin processing. So as we can see in thick provisioning, we can see that from volume A to volume B, there are allocated fixed and unused storage. There are data. They're also allocated in fixed and unused storage and the data. However, in the thin provisioning, we can see that the available unreserved storage are in the volume A and in the volume B are all the datas. So there are also ways to reduce the amount of data that has to be stored without actually shrinking the size of blocks and files. These techniques include the thick and thin provisioning. Okay, moving on. We are now going to talk about the data pre-processing. So companies can use data from nearly endless sources. It can be internal information, customer service interactions, and all over the internet to help inform their choices and improve their business. But you can simply take raw data and run it through machine learning and analytics program right away. You first need to pre-process your data so it can be successfully read or understood by the machines. Now let's talk about what is data pre-processing. So data pre-processing is a step of data mining and data analysis process that takes raw data and transform it into a format that can be understood and analyzed by computers and machine learning. Raw real-world data in form of text, images, videos, and etc. is messy. Not only it may contain error and inconsistencies, but it is often incomplete and doesn't have a regular uniform design. Well, most of the machines like to process data nice and tidy because they read data as ones and zeros. So calculating structured data like whole numbers and percentage is easy. However, unstructured data in form of text and images must first be cleaned and formatted before analysis. So when we are using data sets to train machine learning models, you'll often hear the garbage in and garbage out. So this means that if you use bad or dirty data to train your model, you'll end up with a bad, improperly trained model that won't actually be relevant to your analysis. So good pre-processed data is even more important than most of the powerful algorithms, to the point that machine learning models trained with bad data could actually be harmful to the analysis you're trying to do. So this simply just giving you the garbage result. Well, depending on the data that you're gathering, techniques and sources, you may end up with the data that's out of range or includes incorrect features like household incomes below zero or an images from a set of zoo animals. That is, for instance, actually a tree. So your set could have missing values or fields, or text data, for example, will often have misspelled words and irrelevant symbols, URLs, and etc. Now, let's understand the data pre-processing. So as for my example here, so let's take a look the table here and see how the pre-processing works. So in this example, we have three variables. We have the name, the age, and the company. So in this first example, we can tell that number 2 and 3 have assigned the incorrect companies. So Elon Musk and Jeff Bezos are assigned to the wrong company. So Elon Musk must be on Tesla and Jeff Bezos must be on Amazon. Also, their ages are correct. Okay. So, when we use data cleaning to simply remove these rows, as we know, the data was improperly entered or otherwise corrupted. So, if we use data cleaning, our table should look like this. So, we remove those two rows that are incorrect or that have done incorrect inputs to make our data cleaned. So, it will just leave us with these two rows, which is the Karen Lynch and Tim Cook. Or we can perform data transformation. So in this case, manually, in order to fix the problem, we will switch the Jeff Bezos and Elon Musk. So in this data transformation, we simply transform their data and fix them with their um, right companies. So once these issues is fixed, we can perform data reduction. So how do we perform data reduction? So for example, you want to focus on the age. Um, so you want to focus on who's the oldest company owner in these four company owners. So in data reduction, we can fix the table in the descending age to choose which age range we want to focus on. So for example, we want the company owners who are from 57 and below. So since we descend the age from the highest age to the lowest age, so we can just remove the first row. And that's all for us po. Thank you.
Okay. So again, as our presenter mentioned about their topics, focus actually on uh, data preparation and cleaning. No? So the process of repairing or removing incorrect or corrupted or incorrectly formatted duplicate or incomplete data from a data set is known as a data cleaning, no? So, there are numerous opportunities for data to be duplicated or mislabeled when combining multiple data sources, no? If the data is incorrect, the results and algorithms are untrustworthy, even if they appear to be correct, because the processes vary from data set to data set. There is no one absolute way to prescribe the exact steps in the data cleaning process. However, it is critical to create a template for your data cleaning process so that you know you are doing it correctly every time. No? So, what exactly is the distinction between data cleaning and data transformation? So our presenters now mentioned that data cleaning is the process of removing data from your data set that does not belong there. So the process of converting data from one format or structure to another is known as a data transformation. Transformation processes, also known as data wrangling or data mangling, no, involve transforming and mapping data from one raw data to another for warehousing and analysis. And while the techniques used for data cleaning may differ depending on the types of data stored by the organizations, you can use some basic steps, no, to create a framework for your organization. Number one, get rid of any duplicate or irrelevant observation. So remove any unwanted observation from your dataset, such as duplicates or irrelevant observation. So duplicate observations are most likely to occur during data collection. So duplicate data can occur when you combine data sets from multiple sources, scrape data, or receive data from clients or multiple departments. So one of the most important aspects to consider in the process is deduplication. So irrelevant observation are those that do not fit into the specific problem you are attempting to analyze. Let's say, for example, if you want to analyze data from about millennial customers, but your data set includes observation from older generations, you might remove those observations, and this can improve analysis efficiency and reduce distraction from your primary goal, as well as create a more manageable and performant data set. Number two, correct structural flaws. No? When you measure or transfer data, you may notice strange naming conventions, typos, or incorrect capitalization. And these inconsistencies can result in incorrectly labeled categories or classes. Let's say, for example, yung NA na ginagamit natin or not applicable may both appear, but they should be analyzed as one category. No? The uppercase NA or N/A or uppercase N/A and the not applicable. Okay. Now, number three, remove any unwanted outliers. So our presenter mentioned earlier, there will frequently be one-off observation that do not appear to fit within the data you are analyzing. Because if you have a valid reason to remove an outlier, such as incorrect data entry, doing so will improve the performance of the data you are working with. However, the appearance of an outlier can sometimes prove a theory you're working on. We need to remember that the existing of an outlier does not imply that it is incorrect. The steps is required to determine the accuracy of the number. Consider removing an outlier if it proves to be irrelevant for analysis or is a mistake. Number three, deal with missing data. Missing data cannot be ignored because many algorithms do not accept missing values. There are several approaches to dealing with missing data. Both are ideal, but they can be considered. As a first option, you can remove observation with missing values. However, doing so will result in the loss of information. So keep this in mind before you do so. As a second option, you can fill in missing values based on other observations. However, there is a risk of losing data integrity because you may be operating on assumptions rather than actual observation. As a third option, you can change the way the data is used to navigate null values more effectively. Step number 5, validation and quality assurance. As part of a basic validation, you should be able to answer the following questions at the end of the data cleaning process. Number 1, does the information make sense? No? Is the data consistent with the rules of for its field? Does it prove or disprove your working theory, or does it provide any new information? Can you spot patterns in the data to help you develop your next theory? If not, is this due to a problem with data quality? Because false conclusions based on inaccurate or dirty data can lead to poor business strategy and decision making. So, false conclusion can result in an embarrassing moment during a reporting meeting when you realize your data does not hold up under scrutiny. Because before you get there, no, you must instill a quality data culture in your organization. So to do so, document the tools you might use to foster this culture, as well as what data quality means to you. So under the data collection and acquisition, again, DCA is the process of gathering data from various sources and preparing it for analysis. Some of the most common methods of data collection and acquisition, number 1 is survey. No? Because surveys involve collecting data from a sample of individuals using questionnaires or interviews. Survey can be conducted online, via email, or in person. Number 2 is sensors. No? Sensors are devices that collect data on physical phenomena such as temperature, pressure, or motion. Sensors are commonly used in environmental monitoring, manufacturing, and healthcare. Next will be the web scraping. No, I think everybody are familiar with web scraping. No, web scraping is the process of automatically extracting data from website. So it involves writing code that navigates to a website, no, identifies the relevant data, and saves it to a file or a database. The social media, no? Social media platforms such as Twitter, Facebook, and LinkedIn, no, provide access to large amounts of user-generated content. Data can be collected from this platform using APIs or web scraping. We have also the public data sources. No? There are many public sources of data, such as government agencies, non-profits, organizations, and research institutions. And this data can be downloaded or accessed through APIs also. Last is the existing databases. So existing databases such as customer relationship management system or electronic health records can be used to collect data for analysis. It is important to note that data collection and acquisition must be done ethically and with respect for individual privacy. Organization must ensure that they have the necessary permissions and comply with relevant data protection regulations. Additionally, data must be properly cleaned and prepared before analysis to ensure accuracy and reliability of results. Data transformation. A data transformation is the process of converting data from one format or structure to another to make it more suitable for analysis or to integrate it with other data sources. Some of the most common data transformation techniques are, sabi nga natin kanina, data cleaning. No? Data cleaning involves removing and correcting errors, missing values, or duplicates in the data. And this process ensures the accuracy and completeness of the data. So data normalization, we have 1NF, 2NF, 3NF, 4NF, and so on and so forth. No? So data normalization involves transforming the data to a standardized format, such as converting dates to a common format or converting categorical data into numerical values. No? Our presenter discussed already earlier about the categorical data, no, the numerical values, and so on. Data aggregation. No? Data aggregations involves combining data from multiple sources or at different levels of granularity to provide a summary view of the data. So data encoding involves converting data into a format that can be processed by a computer, such as converting text data into numeric codes or even binary format. The data discretization. This data discretization involves grouping continuous data into discrete categories. So this process is often used in machine learning algorithms to handle a continuous data. We have also data feature engineering. So feature engineering involves creating new features of variables from the existing data. So to improve the performance of machine learning models. And the data reduction. So data reduction involves reducing the size of the data set while preserving the important information. Because sometimes in data reduction, we could remove or delete some important information. So in data reduction, it's just involving reducing the size of the data set while preserving the important. And this process often used to handle big data. So, data transformation is an important step in data analysis process, no? As it prepares the data for analysis by ensuring its accuracy, completeness, and relevance. So by transforming the data into a suitable format, data scientists can gain insights and make better decisions from the data. A while ago, no, during the first presenter, we discussed, we've heard actually the term data cleaning cycle, no, or DCC. The data cleaning cycle is a series of steps involved in cleaning and preparing data for analysis. There are some steps typically involved in data cleaning cycle. Number one, we need to identify data quality issues. These steps involves identifying data quality issues such as missing values, incorrect values, duplicates, and outliers. Number two, develop a cleaning plan. Once the data quality issues have been identified, a plan is developed to clean and address its issue. And this plan may involve inputting missing values, correcting incorrect values, and removing duplicates and handling outliers. Number three is execute the cleaning plan. In these steps, the cleaning plan is executed to clean the data. This may involve using tools such as spreadsheets or programming languages such as Python or R programming. Number four, validate the clean data. So after the data has been cleaned, it is important to validate that the cleaning process has been successfully and the data is accurate and complete. And this can be done by comparing the clean data with the original data, checking for outliers, and performing statistical analysis. Document the cleaning process. This will be the number 5. It is important to document the cleaning process to ensure that it can be reproduced in the future and to ensure that users understand how the data was cleaned. And last, number 6, iterate as needed. If issues are identified during the validation process, then the cleaning plan may need to be updated and the cleaning process repeated. We need to understand that the data cleaning cycle is an iterative process that may need to be repeated several times until the data is sufficiently clean for analysis. Take note, it is an important step in the data analysis process as it ensures that the data is accurate and complete and that insights and decisions are based on reliable information. The last topic is the data reduction. No? So data reduction is the process of reducing the size of the data sets while preserving important information. This is typically done to improve the performance of machine learning algorithms, reduce storage requirements, or improve processing speed. Some common techniques for data reduction. Number one, sampling. No? Sampling involves selecting a representative subset of the data from the original data set. And this can be done randomly or by using more complex techniques such as stratified sampling or cluster sampling. Number 2 is the feature selection. So feature selection involves selecting a subset of the original features or variables that are most relevant to the analysis. And this can be done manually or by using automated techniques such as statistical tests or machine learning algorithms. Number 3 is the feature extraction. Feature extraction involves transforming the original features into a new set of features that capture the most important information. This can be done using techniques such as principal component analysis or factor analysis. Number 4, instance selection. It involves selecting a subset of the original instances or data points that are most representative of the data. And this can be done using techniques such as k-means clustering or density-based clustering. Number 5 is discretization. It involves converting continuous variables into categorical variables by dividing them into bins or intervals. And this can be useful for reducing the size of a data set or handling a noisy data. Number 6 is compression. Now, compression involves reducing the size of the data by encoding it in more compact form, and this can be done using techniques such as Huffman coding, Lempel-Seb-Welch encoding, or run-length encoding. To summarize, data reduction can be a powerful technique for handling big data and improving the performance of machine learning algorithms. However, it is important to carefully evaluate the impact of data reduction on the accuracy and reliability of the analysis, and to ensure that the reduced dataset is still representative of the original data. So I think that's it for their topic.